in the actual proof. Okay, sorry, on the wrong page. Okay, so we're in the middle of the proof of showing that a single tape Turing machine can simulate, and hence is equivalent to, a K tape, a multi-tape Turing machine. And we're talking about the details of how that's done, the various stages in the operation of the single tape Turing machine as it simulates the multi-tape Turing machine. That's sort of where we left off a bit at the previous board. So let's assume, and we'll do a bit of revision as we go through, but now big S is the label we give to the single tape, S for single tape Turing machine, okay? And big M, is it mentioned? Yeah, big M here. That's the label we give to the M for multi-tape Turing machine. Okay, and we're simulating M using S. S will simulate M. Right? So we're now describing the setup of S. You know, what's written on its tape, stuff like that, that allows it to simulate the behavior of M, the multi-tape machine. Right? So S, big S, the single tape machine, its input W, that's its input string. Let's say it consists of n characters. So these characters, these W1, W2, they are single symbols from your string input alphabet. Okay, so one W here for each symbol. So you have an n symbol input. Okay, so now let's see. Now there's only it's a single tape, right? It's S. It only has one tape. So somehow it has to. There's a bit of revision now. It has to put all the information on the K tapes of big M, you know, the multi-tape Turing machine. It has to put all that information onto a single tape. And you remember how we did it? We put the input string on the first tape, okay, and we put the contents of the other K-1 tapes. We put them also on the first string, the only string of S, okay, and separated by. So like what would be here would be the contents of tape number 2, and what would be here would be the contents of tape number 3, and all separated by the strings on each tape of M are separated by hashes, hash functions. Okay, so that's how you put all the information in all the tapes, all K tapes, onto one tape of your S, which only has one tape. By definition, that's what S is, right? It's a single tape Turing machine. All right. Now, at the beginning, when you start, right? So this is stage 1. So first, so S, you know, the single tape machine, on its tape, it sets up its tape in the following way, okay? That it represents the K tapes of big M. So here's your input string, right? You put that on tape 1 of S. Well, there is only one tape, so you put it here, and then you put blank. At the beginning, all the other tapes, the other K-1 tapes, they're all blank. Okay, at the beginning, that's the convention. And so when you initialize all the tapes, if you like, on M, you'll put the input string on tape 1, and all the other tapes will be blank. Right? Now, to represent that on S, big S, you put, like for your second string you just put blank, for your third string you put blank, and so on. And so you would have K-1, because remember there are K tapes on big M, and here's your first, here's the contents of your first tape on big M, becomes your first string in a sense on your single tape on S, because there's only one tape, right? So you'll have the input string here, and then blank, 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 k minus 1 times blanks, and all separated, both on the left and the right, separated by hash signs. Okay, so that's in the first stage you set up your string, your tape of big S in this way. Now that's not quite finished because you need to dot the positions, the symbols where the headers are. Now as these strings here, initially they're just a single blank, but these strings here will expand. I'll explain to you later how that happens. I mean, everything gets pushed up one position to create a space that you can use, and so on. But you know, these blanks here will get expanded, like the strings here. But you need to indicate you need to represent the position of the headers in your big M. Now initially in your big M, your multi-tape machine, the headers, you'll have K headers, remember, there's one head, read-write head, for each tape. So there will be K head positions. So you put a dot over your first symbol here, and a dot over your first symbol here, and so on. So you'll have K of these dotted symbols. Now this W1 dot, now these W's, remember, they are from the string alphabet of your machine, of both machines, S and M. Yes. So each of these can be dotted. Wait a minute. Each of these W's, they belong to the tape alphabet, and you have a finite number of those. So whatever number of different tape, the size of your tape alphabet, the fact that each one of them can be dotted, you have to double the number of symbols in your tape alphabet, right? Like WI and WI dot, you know, for all I's, all possible I's. And similarly for the blanks here, blank dot for your other strings in M. Okay, now stage 2 and 3. You know, now the guts, you know, the real strategy. How do you get this simulating single tape machine to work? How does it work? Right. Well, what it does, now implementing stage 2. It's divide and conquer, right? It's top-down design. When you look at stage 2, you'll say, "Oh my God, that's a hell of a lot of work to do that." Indeed, yes. But anyway, this is we're talking now high-level strategy, right? And we can break it down into smaller parts, smaller stages, sub-stages, and sub-sub-stages, and so forth. Okay, so stage 2. What do we do now? Well, effectively, what you do is you start here, you scan all the way across to the last hash. So that would be the first hash. That would be the k+1th hash symbol, right? Because you've got k strings here. Right? So you scan the whole tape until you come to the last hash. Now, how do you know it's the last? Well, because the next symbol would be blank, right? Okay. And what you're doing, you're reading effectively all the symbols under the heads. So for example, in your first step, so this would be your this is the content of the tape. the tape, one tape, for your S machine at step 0 in a sense. It's this. So then you read